Hello friends, welcome to this lecture of TOC. In this lecture, I am going to discuss on the concept grammar. How grammar is important in a language, we can understand that. A grammar is crucial for defining a language. And what actually a grammar is? Grammar is basically a set of rules that defines how we can construct a meaningful language. So in TOC, we also have the grammar to generate a language. And what is that? Let us check that. So, a grammar, G is basically V, T, S and P. These are the four components that constitute grammar in TOC. And what actually these components are? V basically represent finite set of variables or non-terminals. T basically represent finite set of terminals. S simply represent start symbol, and this start symbol basically belongs to variable. So we always start a grammar with this start symbol, which is nothing but a non-terminal symbol. Then we have P. P is a finite set of rules. Which is nothing but productions. Fine. So P represent finite set of productions, which is equivalent to the rules of a grammar. So this is basically the grammar. And in TOC, a grammar can either generate a string for a language, or it cannot generate a string for a language. Fine. So we can simply say that whether a grammar can generate a string or not generate a string, but we always in a position to obtain a valid language. That means it simply implies that we are in position to obtain a valid string, a valid language. Fine. So we have to remember this, that whether a grammar generate a string or not, it always give us a valid language. And how it becomes possible, let us check through certain examples. So before taking an example, we can define grammar for a language in this fashion also, that for a given grammar, we always obtain a collection of string as a language, and this string would basically belongs to terminals. Fine. Because string is nothing but a sequence of terminals, and that terminal can be of various possibility. We can have various possible string for in a given language. So this star simply represents the various possible string in a language, and in order to obtain this string, what we have to do in a grammar, we have to start with some start symbol, and through a set of productions we have to obtain this string. So this is a very important definition to have the clear understanding how we can generate a grammar for a given language. Basically, once again I am just telling you that a grammar for any language help us to generate a collection of string. A collection of string is basically denoted as terminal and star over it. Fine. This star is basically clean star. And how it becomes possible to generate a string? We always start with some start symbol which belongs to variable, that is non-terminal. And this star represents, this star over the arrow represents using a set of productions, that is rules. We derive a string. So let us take an example to understand this definition. So suppose I have a grammar defined as there is a variable suppose s. There is a variable suppose s. We have terminal as a, and we have the start symbol belongings to variable, and the production that we have is s tends to a, and second thing is s tends to as. Fine. This is basically a grammar. Fine. So how we can derive a language using this grammar? Let us check that. Fine. So as I told you that production as a rule is used to derive string for a given language, and the various possible string that we can derive for a language using these two production of this grammar as number one, if I use first rule, this is a first rule, so I simply put 1 over it. Fine. Using first rule I can derive a string w, and we can say w is a basic, or you can say basic or the first string or the fundamental string for this language. Fine. This is the first string that we have for this grammar for a given language. Then I have as. Fine. Using second production, and this s can further be derived using rule 1 to obtain a dot a. Find this a dot a, which is nothing but a square. So this is a second string. Similarly, I can go successively to define various possible string for this grammar. So in short, what I basically obtain as a language for this grammar as a squared, a cubed, and so on. Fine. This is how we basically define a language over a given grammar. Fine. So for in exam, you would be provided a grammar, and you have to derive a language using the production of that grammar. Fine. This is a basic idea. So let us take more example to understand this thing. So suppose in exam you are provided a grammar. Suppose there is a question. There is a question that you have been provided a grammar. Consider a grammar G as there is a variable as S. There is a variable as S and A, and we have terminal as AB. We have start symbol that belongs to B, and the production, a set of production is provided to you as S tends to lambda, S tends to AS. You can say obviously not AS, it is S tends to SA, and A stands for AA, and A stands for lambda. Or I can say A stands for A. Fine. So this is the question. If it is given in an exam, how we can solve this question? Fine. Let us check that. So what we can do here, that we have to define a language. The question would be, what, or we can say which language can be derived or defined using through above grammar G. Fine. This is the question. So how we can solve this? Let us check that. So the solution would be, see, we have to first start with the start symbol. As I told you, we always have to begin with the start symbol. So lambda would generate the first string. This is our first string. Fine. Always remember, this is the first string that we obtain. This is the first string that we obtain. Fine. Then we have the second production. We have the second production as SA. So what we can form here, we can simply put lambda in place of S. So we can simply put lambda using rule number 1 or production number 1. We can put the lambda dot A, and lambda dot A is nothing but A. Fine. So lambda A is nothing. Now there is a two possibility. Either I can obtain this thing or this thing. So I will start from this thing because it will simply give you A. Fine. It will simply give you A. So it is nothing but A, and when I use the rule number 4, that is production 4, I will obtain A. So A would be the second string. Fine. Similarly, I move on to obtain further string. Suppose once again SA, then using this one I will obtain lambda A or A. Then I would use, this time I will use this production 3, and using 3 I would obtain AA, and this A I can use production number 4 to obtain AA, that is A square, and this would be third string. Fine. Now I am in position to generalize it. Fine, I can generalize it here as that using this production, I am going to obtain a set of consecutive A's. Fine, as far as I am using this production, I would obtain as many A's. Fine, so let us check that I also take another example. Suppose I am using this production once again, and if I move to A, now I am in a position that using this production I can generate as many A's as possible. Fine, this is A. Fine, this is A. Fine, you can understand that. And finally you can end this with production number 4. Fine, we can terminate this with a production number 4. Fine, so we would obtain A in general. Fine, so what would be the generalized language that we would obtain from this grammar? That would be L is equal to lambda as a first string, A as a second string, then I would obtain successive string. Fine, A square, A cube, A4 and so on. Fine, so you can take more example to understand this. In my next lecture I will discuss about more and more example over the grammar. Fine.